Today we're going to talk about special solutions of equations. So I need you to add this title to your table of contents, as well as put it on a new page in your spiral. Special solutions to equations. So when we're talking about a solution, let's remember a solution is a number that makes the equation true. Now, most of our equations, or all of our equations so far, has only had one solution, x equals 2, or x equals 3, x equals -5, but there are a couple other cases as well. So let's just dive in with an example. So let's look at example 1. We're going to solve the equation 9m minus 4 equals -3m plus 5 plus 12m. We're going to see what happens. So our first step is to distribute, but I don't see any parentheses. So then the next step we have would be to combine like terms. Well, 9m and -4 are not like terms. We're just going to drop those to the next step. But we can combine -3m and 12m to make 9m plus 5. Now our third step would be to get your variables to one side of the equation. So if we look at our variables, I have a 9m on the left and a 9m on the right. So it doesn't matter which one you move since they are equal. Since they are equal, I'm going to move the one on the left. So to undo a positive 9m, I'm going to subtract 9m from both sides of the equation. Now I'm going to write a little extra steps that we don't normally write. 9m minus 9m is 0m, drop the -4. And on the right, 9m minus 9m makes 0m, drop the plus 5. Now let's think about what we have here. I have 0 times m. Well, it doesn't matter what m is. 0 times anything is going to give me a 0. -4, and same thing on the right. 0 times whatever m is still a 0, plus 5. Well, if you notice, we don't have any variables anymore. So let's simplify and see what's left. 0 minus 4 is going to give me -4 equals 0 plus 5 gives me a 5. Well, the goal is normally to get m alone and by itself. The problem being is this step here no longer has an m. So we look at what's left over. Since my goal has been thwarted, we need to look at what's left. -4 equals 5. Well, we know that that is not true. -4 is not the same number as 5. So here's the conclusion that we make. When all variables cancel, or I'm going to lose the word cancel lightly, variables, I'm going to put it in quotes because they don't really cancel and disappear. We've talked about that. When all variables cancel and leave a false statement, like we have below, such as -4 equals 5, we say there is no solution. Basically what this means that this equation no longer depends on whatever m is. No matter what value you substitute in here for m, you will never get a true statement. And let's use this blue equation to throw a point. What if I make m equal to 2? 9 times 2 is 18. 18 minus 4 makes 14. Now let's do it on the right. 9 times 2 makes 18, but 18 plus 5 makes 23. -14 does not equal 23. And I could try it with something else. I could try a 1. 9 times 1 is 9. -4 makes 5 on this side. 9 times 1 makes 9. 9 plus 5 is 14. Well, 5 does not equal 14. And this could go on and on and on. Because our m's simplified down to a 0 and we're left with a false statement, no matter what number you substitute for m, you will never get something true out, which means you can never get a solution because a solution is a number that makes the equation true. Now, let's try another example. Let's look at example 2. Example 2. We're going to solve the equation 10x plus 12 equals 2 parentheses 5x plus 6. Step 1 in solving is to distribute. So I'm going to distribute my 2. So I get 10x. 10 times 6 makes 12. Sorry, 2 times 6 makes 12. And then the left-hand side is going to drop. Some of you can see a pattern already, but we're going to continue. The next step would be to move your variables to one side. So again, I have 10x on the left, 10x on the right. Doesn't matter which one we move, so I'm just going to move the left one. And I'm going to write the extra steps we normally skip. 10x minus 10x makes 0x, drop the plus 12. 10x minus 10x makes 0x, drop the plus 12. And again, no matter what number I plug in for x, 0 times anything is still going to be 0 plus 12. 0 times anything is still 0 plus 12. And then 0 plus 12 makes 12 on both sides. So the same kind of thing happened. Our variables simplified to a 0, so they become basically meaningless, and we end up with 12 equals 12. The difference now is 12 does in fact equal 12. That is a true statement. So we have a separate case. So same idea, when all variables, and again, I'm going to use those quotes, cancel, because nothing just disappears. They actually just simplified to a 0. But this time you're left with a true statement at the end. So such as 12 equals 12, 0 equals 0, that is true. 3 equals 3. Then there is, or actually there are, in this case, infinitely many solutions. So those are the special cases of solutions that we have. Sometimes we have many solutions. And let's look at some examples like we did earlier to show you that this does not depend on what x is. It doesn't matter what x is. If I plug in a 1 for x, 10 times 1 makes 10. 10 plus 12 is 22. If I do this side, 10 times 1 makes 10. 10 plus 12 is 22, and 22 is equal to itself. Let's try another one. Let's try a 2. 10 times 2 makes 20. 20 plus 12 is equal to 32. And over here, 10 times 2 is 20. 20 plus 12 is 32, and 32 is equal to itself. We could keep doing this forever and ever. Every value of x we try, we will get a true statement because the left and the right are equal to each other, no matter what x is. Which is why we say there's infinitely many solutions, because there's infinite numbers of x that I could use and make this equation true, no matter what. Okay? So I want you to try a couple things. I want you to do 1, create a no solution equation on your own. Just make one up. Make up an equation that has no solution. And I also want you to make up an equation that has infinite and infinitely many solutions. There are thousands upon thousands of possibilities for these two examples. You guys are just going to make them up. And then we can kind of give some, I'll have you guys share out next class. In the meantime, let's talk about a couple more things. So example 3. This is going to take a little bit of writing for the question part. So example 3, what value of k will make the equation have no solution? Okay, so the equation that we are working with is the following. K parentheses x plus 3 equals 5x minus 6. So let me explain what this question is asking. This isn't necessarily asking us to solve for x. We don't really care what x is. We want to know the value of k that will make this equation have no solution. So we care about this number right here. I need to know what number can I make k in order to force this equation to have no solution. So let's pretend like we know what k is. Let's just solve this like normal. The first step would be to distribute. So k times x would be kx. I don't know what either of those numbers are. K times 3 would be 3k. We just like the numbers in the front. And then equal to 5x minus 6. Now let's think about what we know has to happen for a no solution. I'm going to do that in red. So for a no solution, we have to have variables cancel the x's, and we have to have a false statement left over. Those are the two things that have to happen. So let's think about the first thing that has to happen. 5x and 5x, well, actually just gave the answer. 5x and kx need to cancel each other out. They need to add to 0. They need to add up to 0. So 5, remember, if I want to move this 5 over, I have to subtract it. Well, what does k have to be in order to subtract 5 and make a 0? That means that k would have to be a positive 5. So this is our first thing we're going to try. We're going to try to make k equal to a 5, and let's see what happens. So we have 5x plus 3 times 5 equals 5x minus 6. We're going to try this out. If it doesn't work, we can try something else. Okay, so I'm going to move this 5x over just like I did a minute ago. Minus 5x, minus 5x. So in fact, our x's do add to 0 on both sides. 3 times 5 makes 15, equaling negative 6. So this part here in purple, this made the first thing happen. And now let's check the result. Does 15 equal negative 6? Well, no, it does not. So this made that second thing happen. So basically, in order for this equation at the top to have no solution, k must be equal to 5 to have no solution. Because the value of k equals 5 made us have our variables add to 0, and it made us have a false statement at the end. So k equals 5 is what it has to be. Let's try one more. One more that's extremely similar. So example 4. Example 4. Similar question. What value of k, I could use any letter, by the way, will make the equation have infinite solutions? So now I want the other way. I want infinite solutions. So here's my equation I want to play with. K times x plus 1 equals negative 2x plus 3. So again, let's kind of work through this problem. I want to know what k is in order to have infinite solutions. So I'm looking for this number right here. I don't care what x is. I want to know what k is. So I'm going to start the problem relatively similar as to what I did before. Let's talk about what has to happen to have infinite solutions. So again, the first thing that has to happen is your variables have to cancel, which really just means they have to add to 0. And the second thing that has to happen is this time you have to be left with a true statement. Both of those things have to happen in order to get an infinite solution situation. So let's solve it like we did before. Multiply k in, so k times x is just kx. K times 1, that's actually easier, that's just k, equals negative 2x plus 3. So let's talk about the first thing that has to happen, making our variables add to 0. So I'm going to go ahead and move the variable that we do know. I'm going to move this negative 2 over. I'm going to add 2x to both sides. So let's think about what has to happen to make this equaling a 0. Well, the only thing that'll make 2 equal a 0 when adding is you have to have k equaling negative 2, because 2 minus 2 is equal to 0. So let's start there. Let's try with k equals negative 2. We're going to try that guy out first. So let's substitute it in. Negative 2x plus a negative 2 equals negative 2x plus 3. And let's continue with how we solved it a minute ago. We're going to add 2x to both sides. Make sure our variables actually do in fact add to 0. Negative 2x and 2x add to a 0. Negative 2x and 2x add to a 0. So our negative 2 will drop and our 3 will drop. So now the second thing that had to happen was that we had a true statement at the end. Well, negative 2 does not equal negative 3, so this is actually false. So this would be a no solution case because I don't have a true statement at the end. So that means that k equals -2 is not going to work. Can we think of something else? Is there any other value of k that will simplify a +2 to a 0 when you add? Because we're combining here. We're not multiplying, we're not dividing, we're combining. And there isn't. The only thing you can add to a 2 to make it a 0 is a -2, but we already ruled that out. So the answer to this question is there is no value. There is no value of k that will give infinite solutions. And that's okay. That's not a problem. So we have two cases. Your variables add to 0 and you're left with a false statement. That is a no solution. Your variables add to 0 and you're left with a true statement, and that is infinitely many solutions.